we're going to be looking at a few simpler 2 to 3 conversion factor problems where we're going to take one given measurement and convert it using either common conversion factors or given conversion factors in order to get the answer that the question is looking for. And so I've written a few problems and already gotten them typed and ready, and we're going to work together through these problems so that you can identify what the measurement is and set the problem up in a way that you are able to convert, get rid of the given unit, convert it to another unit, and still have the measurement mean the same thing. Whenever you do a conversion problem, that's the main goal. You have this measurement and you're just trying to express it in a different measurement unit. You don't want to change the value of that measurement. It still needs to mean the same thing, just in a different unit. And so what we have here is we have a medicine problem. And if you look through here, if you just glance, don't even look at the words, you'll see that there's two numbers. Some people look at that and automatically kind of shut down and get confused. But what you want to do is you actually want to read it and try to picture what it's saying, and you want to look for a few key words in the statements. And so here we have an intramuscular medication. It's given at 3.5 milligrams of medicine per kilogram of body weight. If you give 0.275 grams of medication to a patient, what is the patient's weight in pounds? And so if you glance at it, it kind of looks like you're going to convert one mass into pounds, but this is the mass of a medication versus the mass of the person you're giving the medication to. And then there's this other number up here, this 3.5 milligrams. If you look at the entire statement that involves the 3.5 milligrams of medicine, you'll see this keyword per. This word is one that you should automatically kind of clue into. And when you see that, that tells you that the information is not a measurement, it is a conversion factor. So if you see the word per, or you see some kind of abbreviation or symbol that means per, then automatically you should think that this is a conversion factor and I need to write one unit and number versus another unit and number and use it as a conversion factor. And so since this 3.5 milligrams of medicine is part of this conversion factor statement, this will be one of our conversion factors. And so I'm just going to rewrite it and put it into terms of conversions. And so we have 3.50 milligrams of medication per 1 kilogram of the patient's body weight. And so those are two different kinds of masses. The mass of medicine that you take versus the mass of the person's body that's taking the medicine. So this will be able to let us convert between a measurement amount and the mass of the person that's taking it. So that must mean that this other measurement actually is the measurement. And so if you look, it's not just the mass, it's the mass of medication. And so we want to take this statement and write this down first, because the first step that you want to do in a conversion problem is figure out what is the measurement that the question's asking about. In this problem, it actually is in the question. If you give the person this much medication, what is their body weight? So you want the relationship between the medication and the patient's body weight. And so I've got here the mass, but I also put the medication word there because I don't want to lose track of what mass I'm talking about. When you write down your measurement, the first thing that you want to do is you want to think of a conversion factor that will get rid of the unit that you're given, because that is not the unit that you want. And so we have grams. And so I'm going to need to do a conversion factor to get rid of grams. of medication. And the conversion factor that's given to us is milligrams. And so I'm going to switch between grams and milligrams in order to go through this problem and use our new conversion factor. And so this is not any kind of special conversion. This is simply a metric conversion. And so in the metric system, 1 gram is the same thing as 1,000 milligrams. So the grams will cancel out. So I'm going to cancel the grams of medication. Grams will cancel. So now I have milligrams of medication. This is the next unit that I want to cancel because it's not the unit that I want. And this unit matches the unit that's in this given conversion factor. If you're given a conversion factor, you're going to be using it as one of your conversion steps in the problem. And so I'm going to put the 3.5 milligrams of medication. That's this portion of the conversion factor. And I'm putting it on the bottom so milligrams cancels. And then on top, I'm going to put the other part of the conversion factor. And so that will be kilograms of body weight. One kilogram of body weight. And so now the milligrams of medication is going to cancel. And now we're at kilograms, but we want the patient's weight in pounds. And so one of the common conversion factors between the metric system and the standard system is kilograms to pounds. So you can write down your kilograms on the bottom so that it cancels. And on the top, you will want to put pounds. The relationship between kilograms and pounds is one of the common conversion factors that we use in chemistry. And I try to take it to at least 4 digits total. And so that's why I put 2.205. If you want to take it more than that, then you can, but just don't write less than that. That is the same thing as 1 kilogram. And so kilograms will cancel. And now our answer will be in pounds. So you want to take a calculator and you want to use the calculator to do the math that you have just outlined. And so we have the starting measurement, and we're going to multiply it by 1,000, and we're going to multiply it by 2.205, and then we have a 3.5 milligrams on the bottom, so we're going to divide by 3.5, and that gives us a total of 173.25. 173.25 pounds. This is our calculator answer, but our measurement is the number that we started with. When you have an answer and you're relating one measurement to a different measurement unit, your answer measurement cannot be more precise and have more significant digits than your starting measurement. And so you go back and you look at the beginning. Don't look at these ones in between because this is actually a definition, so significant figures don't apply. This is a given amount, and this is a conversion factor where you've used as many digits as you can. We only use the given measurement to figure out how to round it. And so in this given measurement, this first 0 is just there as a placeholder. And then we have the 275. So we have 3 significant figures in our measurement. And so we need to round this to 3 significant figures. So you start at the first non-zero number, and then you count to the third one. And so the ones position will be our 3 significant digits. So you look at the 4th digit and you see it's a 2. And so when you round it, you will just leave it as 173. And so it will equal 173 pounds. This will be our answer for this problem. Okay. In our next problem, we have how many liters are there in 5.3 gallons? So we only have one measurement. So the 5.3 gallons is going to be our measurement. You write down your measurement first. Whatever unit you have in your measurement, that will be one of the units that will be in your first conversion factor, and it will go on the bottom because you want to get rid of it. You want to cancel out the gallons, and the only way to cancel it is to divide by a unit of gallons. So you want to think of a conversion factor that involves gallons. With gallons, unless you're going to something like money, like how much money it costs per gallon of gas, we usually go from gallons to quarts. And since we're going to go from the standard system to the metric system, I use quarts and liters as the switch over between the two systems. And so we want to get used to just saying, okay, we got gallons. First idea to do gallons is to go to quarts. Is that what I want to do? Yes. And so I'm going to put quarts on the top. There are 4 quarts in a gallon. And I don't want quarts, so my next conversion factor will be quarts, and I can go to liters. So you want to think of what the conversion factor, the more you use the conversion factors, the more that you will remember what they are. And so 1 liter is the same thing as 1.0567 quarts. Again, I use as many digits as I can to make sure that my answer isn't affected by what I choose to express as its equality. So we have 5.3 gallons. Gallons will cancel because we have a unit on top and bottom. Quarts will cancel because it's on top and bottom, and that leaves us with liters, so our answer will be in liters. So you want to use a calculator, and now you want to punch in the numbers that you had written in. So you got 5.3 as your measurement, and you're going to multiply by the numbers on top, so you got a 4, and then you have divided by 1.0567, and so we get 20.062458. So I'm just going to write 20.062458, and then it just keeps going. Dot, dot, dot. That is a lot of digits that was on that calculator. This is my calculator answer. You are not done when you have the calculator answer because you need to round it. So you go back to the beginning where your measurement is, and you see that there are 2 digits. Our answer cannot be any better with significant figures than our given measurement. And so we can just write 2 significant figures. So here we have a 2, and our second digit is the 0 in the ones place. So I need my answer to have 2 digits, and so I need to round it based on the next digit. That's a 0, and so my answer needs to be 20 liters. But if you look at just 20 liters and you use significant figure rules, the way I have written it, the 0 is just a placeholder, because the only way to make a 0 at the end of a number be significant is to have a decimal point. And so there's 2 ways that you can solve this, and the easiest way that works every time is to express a number in scientific notation. And so if I want to express 2 digits in scientific notation, then you will write the first number and then a decimal point, and then you'll put the second number after the decimal point, 2.0. But my answer is not 2.0. It needs to mean 20. And so 20, the understood decimal point is after the 0. I need to move it one place. And so with scientific notation, you then say how many places you moved it by saying times 10, and then you raise it to the number of places you moved it. And I just moved it one place. And so times 10 to the first. So that's like saying my answer should be 2.0 times 10, and 2.0 times 10 is 20. The other way that you can solve this problem of making that 0 a significant figure is actually just putting a decimal point after the 0. This only works when you want the ones position to be a significant 0. Because if you had like 200 and you needed the 2 and the first 0 to be significant, you couldn't just put a decimal point anywhere. But if the ones position is the one you need to be significant, you can just add a decimal if that position's a 0. Don't put anything after it. Just leave it like that. So those are the 2 ways that gives us a precise number with 2 significant digits. Okay, our last conversion is just a metric system conversion. When you convert from one prefix to another prefix, what you should do is just use what you know about the prefix. So you don't want to try to learn every possible pairing between all of the prefixes that might exist in the metric system. That is way too much information. But if you learn what each individual prefix means, you can convert the prefix unit to the base unit, and then the base unit to the other prefix unit. So here I have 725 nanometers, so that's about a wavelength in the visible light spectrum. And so 725 is our measurement, so we want to write down that measurement first. And our first conversion factor is going to get rid of nanometers. And so you want to write down what you know nanometers means. And you want to convert it to meters, the base unit. So there's 2 ways to look at it. You can think of how big the meter is versus the nanometer, or how small the nanometer is versus the meter. And so I'm going to just use what most books use, which is what is the meaning of a nanometer. And so a nanometer is a billionth of a meter. And so nano means 1 times 10 to the negative 9 meters. So if I take away the nano unit, I replace it with this times 10 to the negative 9. So 1 little tiny nanometer is 1 times 10 to the negative 9 meters. That cancels nanometers out, but I want to go into centimeters, and so I need to cancel meters, and there is 1 meter and 100 centimeters in an equality. So there's 100 centimeters in 1 meter. So if you go through, you can see that the units will cancel. Nanometers cancels, meters cancels, and when you do the math, you will end up with centimeters as your answer. So we have 725 times 1 exponent negative 9 times 100. And so we end up with 0.0000725. So we have a decimal and then 4 zeros and then 725 centimeters. When you're multiplying and dividing by factors of 10, your significant figures won't really change unless one of your significant figures is a 0. And so we have a really small answer because a nanometer is a really small quantity and a centimeter is a larger unit. You can leave it in this decimal form or you can write it in scientific notation. And so you would write it as 7.25, one number and the rest of the significant figures, times 10. And then you want to see how many places we move the decimal. So it would be one place, 2, 3, 4, 5. But we're moving it to make a small number look larger, and so your exponent will be negative 5, 1, 2, 3, 4, 5, and then centimeters. Either one of these answers means the same thing. Both of them have 3 significant figures.